How's it, Chase? Welcome to another video lesson. Carrying on from last week, today we're going to start with section, let's get the white here. Okay, today we're going to start with section 5.10, which is parallel lines. Okay, so if we've got two straight lines, in order for them to be parallel, they need to have the same gradient. So let's call this 1 and 2. If lines are parallel, M1 is equal to M2. So the gradients are equal. So what they say, okay, so here's an example using this. Example 11, they say calculate equation of line passing through the point 2, 3 and parallel to y equals 2x plus 1. Okay, so we know, because they say it's parallel to this line, and we know the gradient of this line is 2, so we know that m for our new line is going to be 2, and we've also been given this point 2, 3. Okay, so we're going to use, I think they called it point gradient form, in order to calculate the equation of the line. So y minus y1 equals m into x minus x1. Okay, we know the gradient, and here we've got our point, so that is x1, y1. So y minus 3, because that's y1, is equal to m, which is 2, into x minus x1 is 2. Okay, so then we multiply out and we just write it in the gradient form. So y is equal to 2x minus 4. So just multiply that out, and I'm going to take the 3 across, plus 3. Y is equal to 2x minus 1. And there you go. There's the solution to that question. Next they talk about perpendicular lines, which is 5.11. 5.11, perpendicular lines. Okay. So, if you have two lines, and M1 is equal to A over B, M2 is equal to A over D, then if the lines are perpendicular, if 1 is perpendicular to 2, then M1, M2 equals negative 1. Or A over B, I lie. M1 times 1 over M2 is equal to negative 1. So A over B, that's wrong. M1 times M2 is equal to negative 1, which means A over B times A over D is equal to negative 1. So this is the condition for if lines are perpendicular. Okay. So here they give an example. Okay, let me just draw some perpendicular lines so you can see. There's your straight line, and if those are perpendicular, M1 times M2 is equal to negative 1. So then they give an example here, example 12. Once again, calculate the equation of a line perpendicular to y equals negative x plus 1 and that passes through the point 3, 1. Okay, so we know that it is perpendicular to this line and that it passes through this point. So because it's perpendicular, we know that m1 times m2 is equal to -1. So let's say that this is line 1. We'll call the other one line 2. Okay, so m1 is the thing in front of the x, which is -1. -1, m2 is equal to -1. So m2 is equal to 1. Okay, and we also know that the second line passes through this point. So once again, we can use the point gradient form. Y minus y1 equals m into x minus x1. Okay, we call that m2 because we calculated the gradient of that line and called it m2. So we'll use this point, x1, y1. So y minus 1 equals m2, which is 1, into x minus x1 is 3. Okay, so y is equal to x minus 3 plus 1 is equal to x minus 2. And there you go. You've calculated the gradient or the equation of the line that they asked for. Okay. The next section, 5.12, talks about the angle of incline. So the angle of incline is called theta, and it is defined as the angle from the x-axis taken counterclockwise to the line. So there's theta. If we were to draw another graph, for example, let's say this one, the angle of incline would be actually, we need to just double check that. Yeah. Okay, so they say in your book here, they give you a line AB. Okay, and they give you the points x1, y1 and x2, y2 and the angle of incline theta. Okay, and they just tell you there that m, the gradient, is equal to y2 minus y1 over x2 minus x1. Okay, and also that if you look at the triangle that's formed here, you've got a triangle here, okay, and the length of this, so the length of that, the x part of the triangle is x2 minus x1. The length of the y part is y2 minus y1. So tan theta equals y over x. So y2 minus y1 over x2 minus x1. So tan theta equals m, and the angle of incline theta is equal to tan inverse or arctan of the gradient of the line. Okay, easy stuff. Let's move on. Okay, oops, didn't mean to put that line there. Okay, so example 13 says, determine the angle of inclination of the lines passing through the following 2 points. So they give you a part A and the points given are 2, 4, and 8, 12. So let's start off with number A. So first we're going to calculate, and they're asking for angle of inclination. That's the question. Find the angle of inclination of the line passing through these 2 points. So let's determine the gradient first. M equals y2 minus y1 over x2 minus x1. Okay? And we'll say this is 0.1, 0.2. Okay? y2 is, so this would be x1, y1, x2, y2. Easy stuff. Okay, so y2 minus y1 is 12 minus 4. 12 minus 4 over x2 minus x1 is 8 minus 2. 8 minus 2. Okay, which is equal to 12 minus 4 is 8 over 6 is equal to 4 over 3. Okay, and we know that theta equals tan inverse of m is equal to tan inverse of 4 over 3, which is equal to 53,13 degrees. Okay, next I'm going to do the part B, which is similar. So I'm just going to start with that one there. So part B, same question, angle of inclination of a line passing through the points. This time the points are 8, 3, and 2, 9. Alright. So, let's start. Same way as we did last time. Nine minus 3 is 6. 2 minus 8 is negative what? Negative 6. Yes. Okay. M equals negative 1. Now you'll notice the example on the left had a positive gradient. Here we have a negative gradient. Okay. Now what happens with a positive and a negative gradient, I'm going to show you here. So here's a line with a positive gradient. Okay. Here's a line with a negative gradient. Okay. The angle of inclination is always measured there from the x-axis to the line, counterclockwise. Now what you'll notice is that for any positive line, if you look at any positive line, let's draw that one there. We can draw that line there. Do you see that the angle of inclination is always going to be less than 90 degrees? Okay. Whereas for any negative line, the angle of inclination is always going to be between 90 and 180 degrees. Okay. I'll show you there for any negative line. See the gradient or the angle of inclination lies between there and there. Whereas for positive lines, positive gradient, it's going to lie between there and there. Okay. So, let's go ahead and finish this calculation. We know the gradient, m equals negative 1, and we know that So now's where you need to be careful. We said that a negative line always lies, the angle of inclination always lies between 100 or 90 degrees and 180 degrees. So this is the answer that pops out of your calculator. But actually the answer that your calculator is giving you is this angle here. Okay? So in order to get it correctly defined, if you've got a negative gradient, the actual angle of inclination, since m less than 0, theta equals 180 minus 45 degrees is equal to 135 degrees. Okay, so what you need to know here with angle of inclination is when you get, the best thing to do is always just to draw the line, then you can logically see if the angle you've calculated is correct. But with a positive gradient, the answer that you get from this formula here is going to be your final answer. It's correct. Okay. If you've got a negative gradient with a straight line, then this answer, then this answer over here is not your final answer. The actual angle of inclination, you write there, since m is less than 0, theta, the angle of inclination, is 180 minus the value that you calculate here. And that'll give you your correct angle of inclination. So that's just the rule for positive and negative gradients. Okay, let's open up a new page here. Okay. Next they talk about the distance between 2 points, 5.13. Distance between points. Okay. Bear in mind that all of the work we're doing now is only valid for straight line graphs, not for any other functions. Okay. Alright, so the distance between points. Basically what they're talking about with distance between 2 points is if I draw a straight line and I give you point A and point B, they want to know how long is this line. Okay, and I think you can work out very easily how we're going to do that. It's as simple as using Pythagoras' theorem. Okay, because we can form a little triangle like this. This line should be perfectly horizontal. And there you go. Now you've got a right angled triangle. So if you can get the length of this and the length of this, then the length of this line here, so let's call it A, or let's call it R, A, and B. Then from Pythagoras, you know that R is equal to the square root of A squared plus B squared. Okay? So the question is, what is the length of A? This side here. Well, can you see that if we're given, let's talk about these points A and B. Say I tell you that point A is, I want to use the example from your book here. A is 2, 2, and point B is 10, 8. If I told you that, then this line is the difference between these two x points, the length of this line. So A is equal to x2 minus x1, and in this case that is 10 minus 2, and B is equal to y2 minus y1 is equal to 8 minus 2. Okay, and then we can substitute it in there and solve for the length. Okay, but just to make life easier, you are given the formula directly in the book. So the formula is AB, so the distance between points A and B is equal to square root of x2 minus x1 squared plus y2 minus y1 squared, which is exactly the same as what I've derived here, as you'll see. So that's the distance between 2 points. And once again, it doesn't matter which order you select the points in, because obviously the distance from A to B and the distance from B to A are going to be exactly the same. If you walk from here to here or from here to here, you've walked the same distance. So whether I selected this as x1, y1 and this is x2, y2, or if I said point A is x2, y2 and this is x1, y1, it wouldn't matter. Okay, you can select either of the points as x1 as point 1 and either point as point 2, it doesn't matter. Okay, so there's your formula for distance between 2 points. It should be in your formula sheet, so it's fairly easy. Okay, next they've got a nice long exercise. So yeah, let's run through a couple of those. Let's see what we can get done. Okay, as with when I do any exercise for you, I'm not going to do all of them. And I'm going to fly through as many questions as possible, as fast as possible. So that, yeah, I'm just going to try to give you an idea of each of the types of problems that you could get, and yeah, the rest is up to you to do. And yeah, I'll try to do like one of each type of problem so that you get the general idea, and then all of the others should be fairly similar. So questions 1 to 3 say write down the general equation of the following lines, and I am going to do number 2. Okay, and they say do it in gradient form, and you'll remember gradient form is y equals mx plus c. Okay, so I'm going to do number 2, and they tell you that number 2 intersects the y-axis at 2 with a gradient of minus 2 over 3. So we know that the gradient form is y equals mx plus c. You've been given the gradient and you've also been given the c, because c is the y-intercept. So y equals negative 2 over 3x plus 2. And that's that question. Okay. Then we've got questions 4 to 7, which say write the following equations in general form and give the inverse functions. So write in general form and give inverses of the functions. And I'm going to do number 6. Okay, so number 6 is they give you the equation, which is y equals 6x plus 4. And they say write in general form and give the inverse. So general form is ax plus by plus c equals 0. So we've just got to rearrange this equation into that form, and we've written it in general form. So it's just a bit of algebra. So let's do it. Let's take everything to the left. Y minus 6x minus 4 equals 0. And we want the x first. So minus 6x plus y minus 4 equals 0. And generally, I think they don't want a negative. They don't want a to be negative. So we multiply the whole thing through by -1, and that gives us 6x minus y plus 4 equals 0. And there you go. You've written the equation in general form. Next, you have to give the inverse of this function. So, what do we do to get the inverse? We swap x and y, and we solve for y, and we have the inverse. So, the original is y equals 6x plus 4. So, we write swap x and y. So, we have x equals 6y plus 4. Okay, and we solve for y. So, keep doing that. X minus 4 equals 6y. Divide through the whole equation by 6, and we get x over 6 minus 4 over 6 equals y. Okay, and then we can write it as y equals x over 6 minus, this becomes 2 over 3. So, therefore, f inverse of x is equal to x over 6 minus 2 over 3. Done. There you go. We've answered question 6. Okay. Questions 8 to 9 say, convert the following to gradient form. And you'll remember, gradient form is x over a plus y over b is equal to 1, where a is the x-intercept and b is the y-intercept. So let's do number 8. Okay, number 8. I give you the equation 3x plus 4y minus 2 is equal to 0. So, the first thing we need to do is we want a 1. We want our constant in the equation to be a 1, and we want it to be on the right hand side. So let's start working towards that. We want x, y equals 1, right? So 3x plus 4y equals 2. This needs to be a 1. So how are we going to get that? We can just divide the whole equation through by 2. So 3 over 2x plus 4 over 2y equals 1. Okay, so now we've got our 1 on the right hand side like we wanted. Then let's just simplify this a bit. 3 over 2x plus 2y equals 1. Okay, next we want x over a. So we don't want a constant in front of the x or a coefficient in front of the x. Okay. So how are we going to do that? Well, let's start by getting rid of the coefficient of the y. How are we going to do that? We can divide the whole equation through by 2, and then y will be over 1. So let's do that. So we're going to divide by 2. So 3 over 4x plus 2 divided by 2 is 1, so it's y over 1 equals 1 over 2. Okay? And you see now we've gone and made our lives complicated because I've followed the method in the wrong order. So, let's scratch that. Let's start off by getting x and y over a and b, and then we worry about the one afterwards. Okay, so let's try that again. So, let's get x by itself. So we can divide the whole equation through by 3. So, x plus 4 over 3y is equal to 2 over 3. I just took the 2 across and divided by 3. Right. Now, let's divide by the whole equation by 4 over 3, which is the same as multiplying by 3 over 4. Tip and times. So, we multiply through the whole equation by 3 over 4 and we'll get y by itself. So, 3 over 4 x plus y is equal to 2 over 3 times 3 over 4 gives us 6 over gives us, 3 over 4 times 2 over 3 gives 6 over 12. Which leaves us with 3 over 4x plus y is equal to 2. Okay, now let's get a 1 here. So we divide the whole equation through by 2. 3 over 8x plus y over 2 is equal to 1. Okay. And now you'll see, okay, but I've got 3x over 8 plus y over 2 is equal to 1. Okay, but now we know that the coefficient here must be 1. We just want the number a at the bottom there. Okay, so this is fine. We've got 1y over 2 equals 1. So that's fine. And we've got our 1, which is okay. But here we have a problem. So this piece here, 3x over 8, is the same as 3 over 8x. Now this can also be written as x over 8 over 3. If we tip in times, we end up with x over 8 over 3. Okay, because this is the same as saying x over 1 divided by 8 over 3, which is equal to x times 3 over 8. So you see now what I've done there is valid. So we write it like that, and then we will be in gradient form. X over 8 over 3 plus y over 2 equals 1. And we've converted to the gradient form, because now we know what our a value is, we know what our b value is, and we've got a 1 here. So we're sorted. That's gradient form. Okay. The next pair of questions is 10 and 11. Okay. Okay, questions 10 and 11. I'm just going to do number 11 here. And the question says, find the equation of the straight line which intersects the x-axis and y-axis at the following points, leave in general form. So they basically say, find the equation of the line with x-intercept is -1, y-intercept is equal to 1. Okay, and they say leave in general form. Leave answer in gen form. The general form is ax plus by plus c equals 0. So let's use the intercept form just like we used there, because here we can just plug in our intercepts and then we can convert it algebraically to whatever form we want. So because we're given the two intercepts, we're using the intercept form, which is x over a plus y over b is equal to 1. A is the x-intercept, b is the y-intercept. So x over -1 plus y over 1 is equal to 1. Okay, now we just need to algebraically manipulate and get it into general form. So let's start by simplifying this a bit. This is actually a very easy one. X over -1 is -x plus y over 1 is y is equal to 1. Okay, let's get it into general form by getting the -1 across. -x plus y minus 1 equals 0. Okay, and in the general form they don't want a negative. They don't want a to be negative, so we multiply everything through by -1, and that gives x minus y plus 1 equals 0. And there you go, we're in general form. Okay, carrying on. So questions 12 to 16 say, the following are gradients of a number of lines together with coordinates of a point on the line. Determine the equation. So they're going to give gradients and they're giving point on the line. Give the answer, determine the equation of the line and write it in general form. And you know the general form is ax plus by plus c equals 0. Okay, so here I'm going to do two of them. Start off with number 12. Number 12, they give you m, the gradient is 1 over 2, and the point is 1 and 3. Okay, so we're given a gradient and a point, so let's use point gradient form. Y minus y1 equals m into x minus x1. Okay, let's substitute in our point and our gradient. So y minus y1 is 3 equals m, which is a half, into x minus x1 is 1. X minus excuse me. Okay, x minus 1. Then let's multiply out and simplify and get it. Let's multiply out quickly. Y minus 3 is equal to 1 half x minus 1 half. Okay? Now, the general form has got everything on the left and 0 on the right. So let's take everything across to the left. Y minus 3 minus 1 half x plus 1 half is equal to 0. Okay, let's add our two constants. Minus 3 plus a half is equal to negative 5 over 2. So, y minus 1 half x is equal to negative 5 over 2 is equal to 0. Okay, so now let's write things in the correct order. So we put our x term first, minus a half x plus y minus 5 over 2 equals 0. Cool. And they don't like fractions or negatives here, so let's multiply everything through by minus a half to clear the coefficient of the x. So x minus a half. No, we need to multiply through. See, I made a mistake there. To get this to be equal to 1, to get rid of this fraction, we need to multiply through by negative 2. Because negative a half times 2 is equal to negative 1. And negative half times negative 2 is equal to plus 1. And that's what we want in front of our x here. So, let's do that. That gives us x minus 2y plus 5 equals 0. And there we go. We're in the general form. Question is done. Okay, let's see if I've got some space here to do the next one. Okay, the next question I'm going to do is 16, which is the same, except they give you the gradient is 45 degrees, i.e. the angle of inclination, and the point is 1, 1. Okay, so we know that we're given a gradient and a point, so we're going to use point gradient form again. Y minus y1 equals m x minus x1. But we haven't been given m, we've been given theta. So how do we get m? Well, we know that tan of theta is equal to m. So tan 45 degrees is equal to m. Tan of 45 I believe is 1. Let's double check it. Yeah, tan 45 is 1. So m equals 1. Okay, now we can substitute in our points quickly. Y minus 1 equals 1 into x minus 1. So y minus 1 is equal to x minus 1. Take that across and we're left with y equals x. And that's the equation of the line, and we've left it in, this is actually in y equals mx plus c. It's in gradient form where c is 0. Okay, and m is 1. Okay, but they want it in general form. And general form is ax plus by plus c equals 0, right? So let's just write it like that. If we take the x across and leave a 0 on the right hand side, we're left with minus x plus y equals 0. They don't like a negative in front of the x in your book, so it's multiplied through by minus 1, and we're left with x minus y equals 0. And there you go. We've got the equation in general form, 100%. Okie dokie. Let's do a couple more. Okay, question 17. Says, calculate the equation of the line. So find the equation of the line that passes through the point -1 and 2, and that is perpendicular to the line y equals -4x plus 2. Okay. And they don't say what form to leave it in, so we're going to leave it in gradient form. So we're going to leave it as y equals mx plus c, which is the best form. Okay, so let's work with the fact that they gave us perpendicular. We know that if our line that we're trying to calculate is perpendicular to a line, this line, we know that m1, m2 is equal to -1. Let's call this m2. Okay, so m1 times minus 4 is equal to minus 1. So m1 is going to be equal to minus 1 over minus 4 is 1 over 4. Okay, and now we've also been given a point. So we've got a point and a gradient, so let's use point gradient form. Y minus y1 equals m into x minus x1. This point gradient form for calculating is the most common one. It's very nice. So you can pretty much always use it if you know what you're doing. Okay, so here's x1, y1, and we've got m1. Okay, so y minus 2 equals 1 over 4 into x1 is minus 1. So x minus minus 1. Y minus 2 equals 1 over 4 into x plus 1. Y minus 2 is equal to 1 over 4 x plus 1 over 4. Y equals 1 over 4 x plus 1 over 4 plus 2. We needed to take that across. Y is equal to 1 over 4 x. 1 over 4 plus 2 is equal to 9 over 4. And there you go. There's your perpendicular line. Okay. Question 18 is very simple. They say, if a line has a gradient of -1 over 5, what is the gradient of a line parallel to that line? We know that parallel lines have equal gradients. So if a line has gradient 1 over 5 and a line is parallel to it, the gradient of that line is also going to be -1 over 5. Okay. Question 19 says, find the equation of a line that is parallel to y, so it's parallel to the line y equals 2 over 3 x minus 3 and passes through the point -2 minus 1. So here, because the lines are parallel, we know the gradient of the line we're trying to calculate, and we also have a point. So once again, we can use point gradient form. Y minus y1 equals m into x minus x1. And I'm not going to do the calculation because you can just take the gradient there. We've got our x1, which we sub in there. We've got our y1, which we sub in there. And then you calculate it and leave it in whichever form you choose, because they don't say, but leave it in gradient form. Okay. Question 20. Question 20 says, calculate the equation of a line that goes through the point 0, 0 and is perpendicular to the line y equals -x. So, once again, here we've got a perpendicular line, and we know that if two lines are perpendicular, m1, m2 equals -1, right? And the gradient of the line that we're given is -1. So -1 m2 is equal to -1. So m2 is going to be equal to 1. And then we can use our point gradient form. Y minus y1 equals m into x minus x1. Here it's m2 because we're using this gradient. And you substitute in your y point over there, your x point over there, and your gradient over there. And then you can calculate and leave it in whatever form you like. Okay, 21 says if y equals 3 over 2x minus 3, what is the gradient of a line that is, so A, what is the gradient of a line that is perpendicular to this line? So this line's gradient is that. And we know perpendicular lines, m1, m2 equals -1. So you can substitute 3 over 2 in there and solve for m2. And that is the gradient of a line that's perpendicular. And B says, what is the gradient of a line that is parallel to this line? Parallel lines, m1 equals m2. So we've got 3 over 2. Okay. Let's find some blank space. Ah, I've run out. Right. Let's get a new sheet here. Open. Okay. Alright, let's just do a couple more for this video. I think I'm going to finish off this section tomorrow, and then we can start on a new section as well. So I'm going to end here on question 22, because question 22 is just a little bit more interesting. Not much though. Find the equation of line 1 if it is parallel to y equals 2x plus 1. Okay. And they give you a drawing of line 1. So line 1 looks like that, and they give you this. So this is line 1, and they give you the point here, 2, 3. So basically what they've told you is that this point on the line is the point with ordered pair 2, 3. Okay, so the drawing like that tells you that this point is 0.23. Nice and easy. So find the equation of the line if it is parallel to y equals 2x plus 3. So since it's parallel to this line, m is equal to 2. To say, since line 1 is parallel to line with m equals 2. Just give a reason for why you're saying that m equals 2. Okay? And it's since line 1 is parallel to the line with m equals 2. Okay? And then we've also got a point on the line, so once again, it's just point gradient form. Y minus y1 equals m into x minus x1. We know m, it's been given to us because they told us that our line is parallel to a line with gradient 2. So, and we've also got our point. They gave it to us on the drawing, x1, y1. So we just substitute in y minus 3 equals 2 into x minus 2. Multiply out and leave in gradient form. So they didn't instruct what form to leave it in, so you can leave it in any, but as usual I prefer leaving it in gradient form. So y minus 3 equals 2x minus 4. Y is equal to 2x minus 4 plus 3. Y y is equal to 2x minus 1. Okay. And there you go. You've solved your equation of the line that they wanted. And as I said, you can leave it in any form as long as it's one of the forms they've given, but the gradient form, y equals mx plus c, is definitely the better form. It's the most commonly used one. So yeah, cool. Thanks for watching, Chase. See you next time.